So we use integration by parts for integrals right now that when u substitution fails us. For instance, here's an example where we cannot use u substitution. If you look at this and think about what your u would be, there's no way to set it up to get rid of x and dx effectively. So we want to try to use this idea here, and here's how the setup goes. What you need to do is for integration by parts, you need 4 parts. You need u, you need du, you need a v, and a dv. And if you notice up above, there's u dv, it starts, and then it breaks down to u times v and then v du. So what we have to do to begin is we have to take our integral we're given and figure out how can I get a u and a v, and again, or a u and a dv. So we always start working with this diagonal. This isn't arbitrary where you get to pick whatever you want. There is a method to it, and what we'll use is the acronym LIATE. LIATE is a way to pick your u most effectively. So L means logarithms or natural logarithms. I is inverse trig, so inverse trig. A is algebraic. T is just basic trig, and then E is exponentials. So we start and we work down. So if in our problem, if we know we have to use integration by parts and there's a logarithm or a natural logarithm, that becomes our u. So in this case, ln of x is my u. That means everything else will become your dv. So what do I have left? I have x dx. Before I can go and integrate, I need to figure out du, and that simply comes from differentiating u. So the derivative of ln of x is 1 over x dx. And to get v, I need to integrate dv. So if I integrate x, I get x squared over 2. Once I have all 4 parts, I then go and use the formula given here to hopefully be able to evaluate this integral. So I have u times v, so ln of x times x squared over 2 minus v, which is x squared over 2 times du, which is 1 over x dx. So hopefully when this happens, you get an integral here that's easier to break down. There are times when you may have to do integration by parts again. You may have to use u substitution. It could end up being that you have to use a natural log. There's many things that could happen here, but hopefully it's now one that you can use prior rules to solve. So let's finalize this integral here and solve. This part out here will be unchanged. I'm going to bring out the x squared over 2 times ln of x. So I have minus, I have this constant I can bring out of 1/2. I have an x that could cancel with one of those. So really what I have, when I brought the 1/2 out and canceled the x, I have x dx. Now I can integrate this, rewriting the rest, x squared ln of x minus 1/2 times x squared over 2 plus c. Simplify it all, x squared over 2 times ln of x minus 1/4 x squared plus c. And that is the indefinite integral by using integration by parts. Try to use this to look at the rest of the examples we used in class.